Okay, so page 701, number 14 says the focal length of a lens in a box camera is 10 centimeters. So a box camera is one of those cameras from the olden days that sometimes you'll see in films, right? And the person puts their head in behind and you're standing out here to get your picture taken. So, okay, so it's telling us the focal length is 10 centimeters. And it's telling us that in this box camera, the fixed distance between the lens and the film is 11 centimeters. The film is where the image is going to show up, so that's your DI. Okay? And the question wants to know how far must the object be from the lens. So this is back before we could like focus and adjust our lens. So we're looking for DO. So 1 over F is equal to 1 over DO, plus 1 over DI. And so 1 over DO is equal to 1 over F minus 1 over DI. So 1 over 10 centimeters minus 1 over 11 centimeters. Common denominator will be 110. So this will be 11 over 110 centimeters minus 10 over 110 centimeters, which will equal 1 over 110 centimeters. So DO will equal 110 centimeters. So they need to be just over a meter away. Okay? Number 15. Oh, and notice that the image is going to be just beyond F. So it's going to end up being inverted, right? And it'll be smaller. So it'll be between 2F and F. Number 15. A 3 centimeter tall object, so HO is 3 centimeters, is placed 22 centimeters in front of a converging lens. So DO, 22 centimeters. A real image is formed 11 centimeters from the lens. DI is 11 centimeters, and it's real. What is the size of the image? So we're I-ho, di-do, and if we're using what we said in class, we're not putting a negative in here. Okay, so it becomes HI is equal to HO-DI over DO. So 3 centimeters times 11 centimeters divided by 22 centimeters. And you should get an HI of 1.5 centimeters. Okay? It's real, it's positive, which means it's real, and therefore it will be inverted. Number 16. An object that is 3 centimeters tall, HO, 3 centimeters, is placed 20 centimeters in front of a converging lens. DO is 20 centimeters. A real image is formed 10 centimeters from the lens. DI, 10 centimeters. What is the focal length of the lens? I don't know why they told us the height, but okay. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over 20 centimeters plus 1 over 10 centimeters. Common denominator should be 20, so 1 over 20 plus 2 over 20 should be about 3 over 20. So F is equal to 20 centimeters over 3. So F is equal to 6.6 repeating centimeters. Works out to be positive, as it should. It's a converging lens. Did I screw that up? A real image is formed 10 centimeters from the lens. It's placed 20 centimeters in front of a diverging lens. Focal length. The reason I'm asking did I screw it up is because my answer does not agree with the textbook answer. So you'll have to let me know if I screwed that one up. Number 17. What is the focal length of a lens in your eye when you read a book that's 35 centimeters from your eye? So that's your DO, 35 centimeters. The distance from the lens to the retina is 0.19 of a millimeter. So DI, 0.19 of a millimeter. So you probably want to change this to 350 millimeters. So 1 over F is equal to 1 over DO plus 1 over DI. This is not going to be pretty numbers, just telling you. So 1 over 350 millimeters plus 1 over 0.19 millimeters common denominator, I would multiply them together, just because 350 times 0.19 is 66.5. So 0.19 over 66.5 plus 350 millimeters over 66.5. You actually might want to write it as like 1.9 or like to get rid of the decimals, but so on the top here you will have 350.19 over 66.5 millimeters. So F then will equal 66.5 millimeters over 350.19. F will equal, divided by 350.19. F should equal 0.0.189896913 millimeters. Okay, which makes sense. That object is going to be actually a distant object when you have an F that's just 0.19, or a DI that's 0.19, so it's going to form almost at F. All right, number 18 says an object that is 5 centimeters tall, HO, is placed 12 centimeters from a converging lens, DO, 12 centimeters. An image is formed on the same side of the lens as the object. Okay, that means it's virtual. But the image is 61 centimeters away from the lens, so it's going to be negative 61. What is the focal length? So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over 12 centimeters plus 1 over negative 61. They couldn't pick 60 to make this like common denominator easy. 12 times 61. 732. So 61 over 732 centimeters minus 12 over 732 centimeters is equal to 5149 over 732 centimeters. So F will be equal to 732 centimeters divided by 49, right? 5149, yeah. So F is equal to 14.9388. It goes on like 77, but I'm not going to. Okay, that's your F. Can we get the last one done? Number 19. When an object 5 centimeters tall, HO, is placed 12 centimeters, DO, from a converging lens, the image is formed on the same side of the lens, but the image, what is the size of the image? It's like, wait, this is the same question. Negative 61, what is the size? So HI over HO is equal to DI over DO. HI is equal to HO DI over DO. So HI equals HO, which was 5 centimeters, DI negative 61, DO 12. HI equals 12 times, times nothing. 5 times 61 divided by 12. 25.4, and it's negative. 25.416, and the 6 is repeating centimeters, and the negative means virtual and erect. Okay, and you are done. Hopefully those were decent. Okay, the only one I'm worried about, since I still have 30 seconds, is this one that the textbook says the answer is 7.3. An object 3 centimeters tall is placed 20 centimeters in front of a converging lens. A real image is formed 10 centimeters from the lens. That's going to be 3 over 30, right? Like there's nothing, I think it's the textbook and not me, because I can't find it. Unless I can't divide by 20 very